they're just figures that are combination. Oops, they're combo shapes or shaded region. What I'm looking at here, it's either we're going to talk about combination of shapes or shaded region of shapes. When you're talking about combos, it kind of looks like the ones you're asking about from last night, where we had the that rectangle and a triangle fit next to each other. That's a combo shape. You have to do two areas to go to it. Shaded region ones are going to look like shaded region, like picture frame, or like exactly like you asked about earlier, where we had a triangle or a square with a triangle cut out. You're looking at the idea of putting calculators are heavy. You're either adding two shapes together. Combo shapes are usually adding two shapes together. And then shaded region are usually subtracting. Hence why there's a hole cut out of something. I know that you've all done this, and it's not going to be overly crazy, to be honest with you. You guys actually will have more time to work on stuff like this today because yesterday, remember how yesterday we had our discussion about, we had that intruder drill thing tomorrow, but it's not the full intruder part, it's just the lockdown portion. So we talked all about that yesterday, whereas I had forgotten to do that with my classes earlier today. So today they talked about it, and their classes took a lot longer to go through stuff. So they only had 10 minutes, 10, 15 minutes to work on this, whereas you guys will probably have a good solid 25. There's that. There's nothing to this. It's all the same formulas. No, and remember the idea with these shaded region things, guys. I should say this first section of stuff we do in areas. I was talking with Mrs. Thrower about kind of what our pacing, what I was looking at for the rest of this week going into next. Is that what today's Wednesday, right? Yeah. Friday, Monday, Tuesday, Wednesday, Thursday's the half day, and then Friday. Today we're doing we'll probably do composites, the easy stuff today, and we'll do the harder stuff tomorrow. And then Friday we'll start similar figures, similar areas, and then we'll finish that up on Monday. And then Tuesday and Wednesday we're going to do regular polygons. And then this will probably be a whole bunch, the half day because of the conference stuff would probably be the review, and then Friday would be the quiz over all the first. Would be the quiz over the first few sections of what we've done. In all honesty, the first set of problems really are only out of it's only really 4 sections. Right? It's really technically only 4 sections. And guess what? It's not this Thursday. So guess what you get to have for next Friday though? Formulas. Yeah, I won't make you guys memorize formulas. Okay. It's a formula sheet. I'll give you a formula sheet. So what we do is, excuse me. What we do usually when we get into the areas and volumes and surface areas and stuff like that, we usually give you guys the same exact formula sheet that you will see when you get to the final. So that way you know what's on that, so you know what formulas and things you'd have to remember. Remember, I will always give you guys the law of science, so I have that. I don't think I'll ever make you do a law of science problem for an area, though. That'd be pseudo-mean. We can do it. It's pretty easy. But all the rest of these formulas, area of rectangles and trapezoids and all that, you don't have to memorize them. I mean, you probably already know most of them anyway, but you don't need to memorize them. Okay? That's kind of what we're looking at. It shouldn't be so bad. Question on that at all? Good times. Yeah, that shape is clear. Well, I can do that, but I feel bad. Why not? No, I I ran off pictures so you don't have to draw them. No. What part of I ran off pictures so you don't have to draw them did you not understand? I know. He's new. What's that? You'll get over it. So what I wanted to do here with these is I wanted to use some of these as examples of what the composite figures look like, what do the composite shapes look like, what does it mean as far as trying to guys, what does it mean as far as trying to decide what parts are heights and bases and moving things back and forth, what does it look like when you have holes cut out of things and so on and so on and so on. So one of the things I like to start with is just right there on number 1. If you look at number 1, I'm on the one without any holes in it. Okay. We'll do the other side of it in a minute. So I'm looking at that one. So if you look at number 1, if you look at that, you've got your dimensions. And this is what we call a composite figure. There are 2 shapes put together. What are the 2 shapes? A square and a rectangle. So as we get going into stuff like this, I always, always full of suggestions. It's going to be really important that we identify what our main parts are going to be. Not so much now because it's really easy. But as we get into surface areas when things start to get a little bit crazier, understanding what your main bases are is pretty important. So you have an area of a square, and you're adding to an area of a rectangle. Yeah. And just take a second and write down the 2 shapes you're working with, because then you can reference your 2 formulas. Side squared plus a base times height. Okay. And you guys have that one. We had listed out all of our formulas. So which one is the square, the 12 by 12 or the 12 by 20? 12 by 12. Whew, that was tough. I know. Yeah, all right, let's take a quick 5-second pause. What's 12 squared? And let's see, that's 240. Add them together, you get 384 something squared. All you're doing is just putting them together. This is pretty easy stuff. I mean, we can make this more difficult if you'd like, but we tend to try to make this pretty easy to start with because.
You can put hour. Yeah. Page hour. I thought it was hour.
Oh, it looks like a units. Something squared. Whatever. At least I labeled something squared, and that's all that matters because it was a shape. I didn't know what this units were. Okay. Now, what changes from that into look at number 5? Because I'm mixing around the different parts. Yeah, that's pretty decent. What are your 2 shapes? Why do you say it's a semicircle? All right. Do you guys know what makes a semicircle? Okay, thank you, Captain Obvious. Welcome back to our class. No, seriously, the definition for a semicircle is that a semicircle is created by a diameter. And a diameter is something that's a segment that goes through the center of the circle. Okay? That's why we know it's a semicircle, or that we know it's half of a circle. So a semicircle has how much of the area of the circle? Half. Oh, why do you think that is? Because it's half of a circle, exactly. Now, A semicircle is technically, you ever heard the term called a sector? Okay. Have you ever seen pizza cut in pie shape? Okay, each piece of pizza that's cut in pie shape is a sector. A sector is defined by, let me show you real quick, we'll go back to this.
Okay, I have a question for you.
Each one of those pieces, albeit not drawn to scale, doesn't matter. Whatever. I'll get over it. So what's happening here is that each one of these parts has their own angle, their own wedge, if you will, their own theta value within the circle. We know that all of those degrees have to add up to equal how much? 360, because it goes all the way around. Now, each piece of the pizza also has the same radius. You agree?
Yeah.
So the amount of area is defined by the ratio of the angle to the overall circle times the area of the circle. So when you guys were saying a second ago, this sector would be called whatever the angle is over 360 times pi r squared. Well, how many degrees is in a semicircle? 180. So if I had 180 degrees, this much of the circle would be 180 over 360. What's 180 over 360? 1/2. It's just a simplified fraction. That's why a semicircle is half of the area of a circle.
Okay.
You just look like a guy who lost you completely. Sorry. Anyway, so you have a circle, a semicircle, so it's going to be half of pi r squared. And to that, you have to add a triangle. Formula for a triangle is a 1/2 base times height. Oops. In this problem, though,
No.
you know what your radius is, don't you?
Yeah.
What's your radius? Your radius is 6. Okay. What's your diameter then? 12. The radius is 6. It makes your diameter 12. So what's the height of the triangle? 12. So sometimes you have to put parts together because you're given this radius here at 6, which means these two are 6, which makes this whole thing 12. So that's when you start putting it together. You get 1/2 6 squared times pi plus 1/2 12 by 18. It's really not all that difficult to do any of this. It's just a matter of making sure you understand where your parts are coming from, where your shapes, what your shapes are, and what the dimensions or the size of the shapes wind up being. Now you can put all that together in the calculator, press a button, you're going to get decimals. Yes, ma'am.
Never.
Or you can leave it in what's called exact form. If you had to leave it in exact form, that means you'll leave your answer in terms of pi. Well, what's 6 squared?
36.
What's half of that? Half of 36 is 18. So yeah, 18 pi would be the area of the semicircle. And then what's half of 18? 9 times 12. Well, that means it's 9 feet has how many inches? It would be 108. So this would be, I don't know what the units are, but that would be what your answer would be in terms of exact units because you leave pi in the answer. If it asks for your decimal, you just basically press enter and it gives you the answer. What do you get when you're on 2 decimals? 160.
35.
Was it centimeters?
Yeah. Yeah. Good job.
Thanks.
Thank you.
Okay. And it's quite literally just pressing some buttons, guys. You're mixing together a couple of different parts as far as areas. All right. Take a second. You guys do number 7. Take a second and do number 7. We'll check it here in a second. I want to make sure you guys get this circle. Turn it off. That looks awful. It looks like it's a very saggy diaper. Thank God my children. We have a very dirty diaper and a triangle. What is the radius of your semicircle?
4.
What is the base of your triangle?
8.
So you have a 1/2 base times height plus a 1/2 pi r squared. And just put it together. 1/2 of 8 by 6 plus 1/2 4 squared times pi. So if you put it all together, this is 24 plus, what was that, 16, 8 pi. When you multiply that out, would you get 48-ish? That's close. 49.13. And then I forgot our units. This is not the right sheet, so.
Feet.
Feet.
We don't have it.
I'm going to ask you to round it to. It depends. Your calculator sometimes will leave it in that simplified radical form, and sometimes it'll give you decimals. So if it gives you a decimal, just write out the decimal. If it leaves it in simplified radical form, you can write it in simplified radical form. Does that make sense, Thomas?
Yeah.
Either one of them is fine by me. Okay. Now flip it over real quick. I want to talk about things with holes cut out.
What was the decimal? 5.
This is number 3. Close. Number 3. Now, when you look at number 3, it's really not even close to being normal. If you look at this one, besides the fact that it's horribly drawn, but yours looks great. Mine's pretty bad. One of the things you'll notice that you have a rectangle and a semicircle cut out of it. You all right with that? When you have a hole cut out of something, what do you have to do with the areas? Subtract. That's all you do is subtract. So first thing we have to figure out is we have a rectangle. Subtract half of a circle. So we always want to write down what formulas we're going to use before we do it. Now we've got the base of the rectangle is 3. What's the height of the rectangle?
4.
4. Very good. It's got to be 4 because notice it's got the radius of that semicircle is 2. Which means if you move it around, you get a full diameter that of 4. Does that make sense?
Yeah.
So you get to 3 by 4. So we have a 3 by 4. And then we have to subtract out a 1/2 2 squared pi. So we have 12 minus 2 pi something squared, whatever it was. And then again, obviously, you would press buttons in the calculator, you get 5 something, and go from there. Okay? All right. Take a second and try 5. Do 5 real quick. Let's see if we can make this.
-7.
Can you have an area that's negative?
Yeah.
How do you have a negative area?
I don't know. We just have it in right.
You have negative area. I'm pretty sure you didn't put it in right.
Well, let me see. Yeah. She did do it right.
Pretty sure she did.
Wait, no, she's. I don't know. Maybe it's the other way around. Maybe I was. Yeah, that's true. No, you're not supposed to. Oh, you're not supposed to.
So this is a shaded region problem. What's the larger of the two shapes? The square is the larger of the two shapes. Okay. So the square is the larger of the two shapes. So how do you find the area of a square? Side squared. So we have a square. And what do you have to subtract out? Okay. And just like Chris just said, that our area of our square is just side squared, so it's just 14 squared. Now, if 14 is the diameter of that, what's the radius going to be?
What?
14. 14 is the diameter. What's the radius? 7. 7. Very good. And again, you're quite literally pressing some buttons in the calculator. Make sure that you square it before the pi, because if pi isn't squared, the radius is squared. Because can you have negative areas?
No, what I did is I put 12 minus 2 pi squared.
Okay. Finish this. And then what?
You go to the doctor. You might die. You might die. Okay, 7 squared.
I don't know. Hey guys, what did you guys get for a decimal on that one? 42-ish?
I have 7 views.
Hey, guys, you crack it, and then keep out the one and grab the change real quick.
Add squares. No, like, okay. So did I have it in the half? No. Why did I have to do it on 3? Are you kidding me?
Guys, let's have a seat and get working.
Which one did you want to do?
All of them.
Okay, what did you say?
What? No, I have to go get changed. And I'll be right back. Get working.
Yeah.
Go.
Yeah, sure, dude.
Yeah. So I'm ready. Yeah. Oh, no, it's how did you do you? Oh, no, she tried to shoulder check me again, okay? And I'm like, that's all you can do is shoulder check me. Go some and hit me. Right? And she said something, I'm like, that's what you do with so, and then she said something like, you see me right now. And then she tried fighting me. But like, even hard, you can't hit hard. So like, I couldn't hit hard. Oh, yeah, square is long. Size square.
Look, I've got sunglasses.
Have a 25. Wait, and then we have to put the half.
You're right, 20.
Wait, there's for floor circle. Radius, the little ones are radius. Why do I do it's high times oh, I see why he didn't have a this is a circle. Why do I keep doing like that? If I can I don't have it again. For that, it's just times the radius for not half of it. It's not
No problem. It's March, you should know where it is.
okay. That would be
There was some update, and I got there was some weird update that went through, so that's what it was.
it'd be half for number 3.
That one, yes, we did all of them. And all the formulas are written on the top of the sheet.
5 squared is 25. Half of 25 is 12.5. And pi. It's 24. Yeah. It's just squared, right?
Yeah, because I'm calculating all that. We're not selling them to make money. We buy them for
This is a rectangle.
so we sell them. We sell them for 15. Rather than, I think we actually lose at 15. We barely break even, or we actually lose a we just haven't used No, we'll buy,
Half of the basement.
we'll buy 5, 6 boxes at a time. We'll buy them for
Because like this whole thing right here is 14. We only have this one, these 2 other things, so 7.